students, I hope your preparation is going good. If not, don't worry. Sri Gurukula is here to help you. And I am Anmol Yadav. I will be your physics and mathematics mentor. I am an NIT-JEE graduate. So bring out your books. Let's make your preparation stress-free. Today we will be discussing all the mechanics questions from the KCET's 2024 paper. So let's start. Our first question is, an athlete runs along a circular track of a diameter 80 meters. The distance traveled and the magnitude of the displacement of the athlete when he covers 3/4 of the circle is. In meters we have to give the answer. So according to the question, there is a circular track on which an athlete will run. So let's suppose he is starting from this point and it is running 3/4 of the circle. 3/4 of the circle means he started from here, he completed 3/4 part, means this much part. He started here, ended here, correct? Now we need distance and displacement. How much distance he traveled? He traveled this distance, correct? This entire distance he traveled. So from here to here, which is 3/4 part of the circle, which is 3/4 part of the entire circumference. So distance, total distance traveled by him will be equals to 3/4 of the circumference of the circle, which is 2 pi into r. And what is r? See, 80 centimeter is the diameter. Diameter is equals to 80 meters. So radius will be equals to 40 meters. So that 40 meters will keep here. So into 40, 4 ones are 4, 10s are 3 2s are 6, 6 10s are 60, 60 pi. So distance traveled by the athlete will be 60 pi. So our correct option will be A. Now let's check the magnitude of the displacement as well. So what is the displacement? Displacement is the shortest distance between the initial position and the final position. And what is the shortest distance? Just make a straight line between initial position and the final position. So if you will see, this is a right angle triangle with right angle here, and this is radius, this is radius. So in a right angle triangle, these two sides are equal, then this other side will be root 2r. Why root 2r? You can simply use Pythagoras theorem. Let's suppose this side is c. So c square will be equals to r square plus r square, or c square is equals to 2r square, or c is equals to r root 2, correct? So this length is r root 2. So displacement will be equals to r root 2. And what is r? R is 40. So 40 root 2 is our displacement. You see the correct option? It is 40 root 2, correct? Now let's see the next question. Among the given pair of vectors, the resultant of two vectors can never be 3. Which the vectors are. So we have some options, and which two pair can never form a resultant 3. So to solve this, we need to know this concept, that resultant of any two vector will always be between mod of a minus b to mod of a plus b. This is magnitude of a, magnitude of b, that difference, magnitude of a, magnitude of b, and their addition. So let's see. First option, option A and B are 2, so their difference, magnitude of their difference is 1, and this is equals to sign, okay? Less than equals to and greater than less than equals to. So it is greater than equals to 1 and less than equals to 2 plus 1, which is equals to 3. So in this case, it can be equals to 3. Now let's see option B. According to option B, it is 2 and 5. Their difference is the absolute difference is 3. So it is between 3 to their addition is 7, so between 7. So it is between 3 to 7 and it can be 3. So this is not also our correct option. Now let's see option C. According to option C, their absolute difference will be again be key. Their absolute difference again will be 3, which is 6 minus 3, it is 3, and their addition will be 9. So it is between 3 to 9 and it can be equals to 3. So this is also not the correct option only. So correct option will be option D. Still let's check it. So option D, their absolute difference, if you will check, 8 minus 4 will be equals to 4, and their summation will be 8 plus 4 will be 12. So 3 is not between 4 to 12. So this is the only correct option, correct? Now next question. A block of certain mass is placed on a rough inclined plane. So this is the block, it is placed on the rough inclined plane. The angle between the plane and the horizontal is 60 degrees. So this angle of the wedge is given as 60 degree. The coefficient of the static friction and the kinetic friction between the block and the inclined plane is 0.6 and 0.5. Means coefficient of static friction mu s is 0.6 and coefficient of kinetic friction mu k is equals to 0.5. respectively. The magnitude of the acceleration of the block is, so what will be the acceleration of this block? So if you will see, let's suppose the mass of the block is capital M. So this is, there will be mg force, correct? So in the downward direction, if this is angle theta, this is 30, then this angle will also be 30 degree. So let's divide it into components. So mg and mg cos theta, this is mg, this will be mg cos theta, and along the plane it will be mg sin theta, mg sin theta, and friction will be against it. Now for this block to move, this mg sin theta should at least be greater than the static friction. So for block to move, mg sin theta should be greater than static friction, So let's calculate both the values of static friction and mg sin theta. So our mg sin theta, m value unknown, g is, let's take it as 10, and sin theta, sin 30 will be equals to 1 by 2. So this is equals to 5m, correct? 5 times the mass of the block is this force. Now this F should at least be, now this F should be less than 5m if the block, for a block to have acceleration, or else the block will remain at rest, means the acceleration will be 0. Now let's try to check this static friction, if it is less than or equals to mg sin theta. So static friction, we know that it is mu static into normal. Now what is this normal? Normal always acts perpendicular to the surface. Here this is our surface, so perpendicular to this we will have a normal force, and since there is no motion in this direction, means this normal force is equals to mg cos theta. So normal is equals to mg cos theta. So let's place everything here. So this will become, so static friction value is 0.6 into capital M, this is capital M, it is mg, and cos 30 degree will be root 3 by 2, and g let's take it as 10, m into 10. So 10 into 0.6 will become 6 m root 3 by 2, 2 ones are 2 threes are, so this is equals to 3 root 3m, which is approximately equals to 5.19 m. So if you will notice, static friction value is greater than mg sin theta, means the block will remain at rest. So our correct option will be, acceleration will be 0 because the block is at rest. Now let's see the next question. A particle of mass 500 gram is at rest, means initial velocity is 0, u initial is equals to 0. It is free to move along a straight line. The power delivered to the particle varies with time according to the following graph. This is the power and time graph. The momentum of the particle is. Now, since we have power and time graph, we know that area of power time graph, area of PT curve gives work done. Correct? So overall work done will be equals to area under this curve, means this area of this triangle plus area of this rectangle. What will be area of this triangle? This is a right angle triangle, so area will be equals to half into base is 5, into height, this length is 8 minus 2, which is 6, plus area of this rectangle, so length is 2, breadth is 5, so 2 into 5. So this is our area of this PT curve, and it will give us the work done. So this, if you will calculate this, it is 5 ones are 5 threes are 2 ones are 2 threes are 5 threes are 15, and 15 plus 10, it will be equals to 25 joules. So our work done is 25 joule. Now we are supposed to find momentum. So what we can use, since we have work done, we can think about the work energy theorem. We know that according to work energy theorem, overall work done is change in kinetic energy, and our initial kinetic energy will be 0, means work done is equals to final kinetic energy, and work done is equals to 25 joules, means 25 is equals to final kinetic energy, which is half mv square. Now let's multiply by V and divide by multiply by M and divide by M. Now M into V is momentum, so this is equals to momentum square divided by 2M. So 25 momentum square by 2, and M is given in the question is 500 grams, means in kg if we will calculate it will be half kg, and this is equals to 25. So 2 and 2 will cancel out and momentum square is equals to 25, means momentum will be equals to 5 Newton second. Correct? So any option can we see 5 Newton second? Option C is the correct answer. Now let's see another question. A ceiling fan is rotating around a fixed axis as shown in a figure. This is the axis through the center. The direction of the angular velocity. So here we will use screw rule if you know. So we will rotate our finger in the direction of the rotation of fan, and our thumb will give us the direction of angular velocity. So it is downward, means minus z direction, which is minus k cap. So correct answer will be option D. Now let's see another question. A body of a mass 1 kg is suspended by a weightless string which passes over a frictionless pulley of mass 2 kg as shown in a figure. The mass is released from the height 1.6 meters from the ground. With what velocity does it strikes the ground? So if we release the system from here, initial velocity will be equals to 0, and when the block will reach here, it will have some velocity v, let's suppose small v, okay. So what we can do here, we can apply energy conservation. Initial energy and final energy will remain same because everything is frictionless, correct? So no loss of energy means initial kinetic energy plus potential energy, kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. Now potential energy for this pulley will not change because it is still on the same height. Potential energy for this block will change and kinetic energy for both will change. So initial kinetic energy is 0 because system released from rest, but initial potential energy we have something here, correct? So initial potential energy is mgh. M is 1 kg into gravitational acceleration, which is let's take it as 10, and height 1.6. So this is potential energy of this block. We are not writing potential energy of this block. Why? Because initially and finally it is at the same height, it is going to cancel out, correct? So initial energy is equals to final energy. Now finally potential energy will be 0 because this block is at ground, correct? And this block still at the same height as initial, so they are cancelling out each other. So final potential energy is 0. Now final kinetic energy of block plus kinetic energy of pulley. Here the pulley has a mass, correct? So we can't ignore the kinetic energy of pulley. If this is going down, this string will rotate this pulley with the same velocity. See, it is a single string. So if this block has velocity v, means this point has velocity v, this point has velocity v, this point has velocity v, and this point has velocity v in this direction, correct? So if this point has velocity v in this direction, finally what will be the omega of the block? Omega, we know that angular velocity v by r, correct? So omega will be equals to v by r. Now let's write this thing. So after calculating this, it will become 16 is equals to kinetic energy of block is half mv square, half mass of this block into velocity of this block v square. Now kinetic energy of a pulley is like a disc. So kinetic energy, we know that it is half I omega square, where I is the moment of inertia. Moment of inertia of a disc, if you remember, it is mr square by 2. So let's put that value here. So this 16 will be equals to v square by 2 plus half. Moment of inertia for a disc will be mv square by 2, and m is 2 kg. So 2 into mr square. Let's suppose the radius is r. So mr square divided by 2 is the moment of inertia into omega. Omega is v by r. So v by r whole square, correct? So this will be 16 will be equals to v square by 2 plus this 2 and 2 will cancel out, 1 by 2 times r square v square by r square. So r square cancel out, V square by 2 plus V square by 2 will be equals to V square. Means 16 is equals to V square. Means V is equals to 4 meters per second. 4 meter per second will be the velocity of the block. Do we have any option? Yes, we have option D as our correct option. Now let's see another question. What is the value of acceleration due to gravity at a height equals to half of the radius of the earth from the surface? So this is the earth and this is the radius of earth. Okay, this is our earth, this is the radius r, and this is the point. Now we need gravitational acceleration at a point which is r by 2 distance. This is our point P, which is r by 2 from the surface of the earth. R by 2 from the surface of the earth. So at the surface, we know that G is equals to Gm by r square. This is small g value we have calculated, it is Gm by r square. Now at this point P, how will you calculate gravitational acceleration? It will be G at this point P, G at point P will be equals to Gm, and this r is the distance from the center divided by, what is the distance from the center? Distance of from the center is r plus r by 2, which is 3r by 2. So square will become 9r square by 4. So this will be equals to 4 Gm by 9r square. Now Gm by r square is actually small g. So gravitational acceleration at point P is equals to 4 by 9 times 9.8. Now let's multiply this and calculate this. So 9.8 into 4. 8 4s are 32. 9 4s are 36 plus 3 will be 39 and 1 decimal. So 39.2 divided by 9. So let's divide it by 9. 39.2 divided by 9. It will be 9 4s are 36. 3.2, a decimal point here. 9 3s are 27. Difference will be equals to 5 and 0. So 4.35 something. Any value which is close to 4.35 or option A is the correct option. Now let's see another question. A thick metal wire of density rho and length L is hanging from a rigid support. The increase in the length of the wire due to its own weight is. So this is a good question. So we have a rod, a thick rod which is hanging from the ceiling like this, correct? So what will be its change in length due to its own weight? So how we will calculate? What we will do, from the bottom we will go at x distance and we will take a component dx component of mass dm, and we will integrate this and we will find the change in length of this and we will integrate it along the length. How we will do that? If we will zoom it out, it is actually, this is our component of dm mass and length dx. Now which force is acting on this mass? This mass has been pulled down with, because of this mass. This dm mass has been pulled down due to this mass, because this mass has some weight. It is like we have below this, we have another mass which has a weight, which has some weight. If the entire body has a density of rho, means rho is equals to, let's suppose the entire rod has mass m and length L. So rho will be equals to mass divided by volume. Mass divided by volume, correct? Mass by volume, and this will be equals to, the density will be same for this dm mass as well because it is from the same material. So dm and area of this is actually still A divided by area, and length of this mass is dx. So from here we can calculate dm mass. So dm will be equals to rho A dx. dm is equals to rho A dx. Now if entire mass, see, mass m has length L, so this x length will be having how much mass? It will be m by L into x. So this mass will be m by L into x. If we'll multiply by area and divided by area, this is rho. So this is equals to rho A x is the mass of this lower part, correct? So force on this part will be equals to rho A x g. Correct. Now we know that Young's modulus is stress by strain, force divided by area, delta L by L. We are supposed to calculate this delta L. So delta L is equals to F L divided by YA. Now delta L for this small mass will be small. So D delta L will be equals to force on this small mass. This rho A x g into length of this small mass is dx divided by Young's modulus into area. So area and area will cancel out. Correct. And now let's integrate this to find the overall change in length. So overall change in length will be delta L is equals to rho g and y are constant. Rho g and y are constant. Rho g y everything is same, right? Rho g and y are constant. Integration of x dx will be equals to x square by 2. Limits from 0 to L. By 0 to L, because we started from here and we'll go till here. So starting from 0 going till L. Correct. So 0 to L. So our final answer for delta L will become rho g L square divided by 2y. Rho g L square divided by 2y. Do we have any option? Rho g L square divided by 2y. Option B is the correct option. Now let's see the last question for today is water flows through a horizontal pipe of a varying cross section at a rate of 0.314 meter cube per second. The velocity of the water at a point where the radius of the pipe is 10 centimeter. So it's like something like this, pipe like this. Okay, so different places the area of cross section is different. So what will remain constant? Q is equals to A into velocity. Area into velocity remains constant. And area into velocity is given as 0.314 is equals to area into velocity. So when the area is pi r square, where r is given as 10 centimeters. So when area is pi 10 centimeter square, at that time what will be the velocity of fluid? So area will be equals to pi, r in terms of meter we will write, so it will become this will convert in meter, so it will become pi into 1 upon 10 square. Area into meter, centimeters into meter will become 1 by 10, means 10 divided by 100 will become 1 by 10. So 1 by 10 square means 1 upon 100 into velocity. This velocity we are supposed to calculate. Correct. So velocity will be equals to, this will multiply here, it will become 1.4 divided by pi, which is 3.14. So 1s and 10s. So velocity is equals to 10 meters per second. Do we have any option 10 meter per second? Option C is the correct option. So this is all for today. I will be back soon. Till then, keep practicing. This is Anmol Yadav from Sri Gurukula signing off.